3. Physics Deep Dive.
All right, so this is a supplemental footage to do some error analysis. This is I'm calling this part A because I'm going to refer to it later. Right now, doing a little experiment to compensate for pulley friction. And what I'm trying to do here is figure out how much mass to put on that left hanging mass so that it moves, so it's in equilibrium. So it would stay at rest, and if it started at rest, and move at constant velocity if I give it a push. So the first thing I did is just to get a general idea, I put a bunch of paper clips on until it started moving, until it accelerated, and clearly that was too many. You can count how many I put on. And I just laid them on to quickly do that, and now I'm clipping them on so I can do some experiments without them constantly falling off. All this material was shot on the same day. It was the day of the original experiment. I kept the integrity of the two masses. The one that's on the left now is always on the left, and the one on the right is always on the right. All right, so here I got a wider shot, and now they got a kind of a sense of how the masses react to the paper clips. I've taken all those paper clips from the first one, and you can see I pulled looks like one or two off. I can't tell. I'm going to spread them out further, but if you take a look on the landing block, you'll see paper clips there. Looks like there's two. So I took two off of the maximum number that I had originally. And now there's three off, you can see. Looks like it's still accelerating. If I just hold it and let go, it doesn't stay where it started. So there's definitely not force on this at this point. So removing another one. So clearly there's some sort of asymmetry going on with the pulley. right mass, left mass. So this is new. 1 paper clip, 2, 3, 4. All right, that was the 4 that was hanging on there before. Here's the 5th one. It was also on there. So these last 3 are the ones that were sitting on the block the whole time. On the block. Here's the mass of the pulley. There's the string. Dimensions of the pulley. And I have a shot coming up showing that the ruler was in the center. It was positioned in the center. And there's the shot right there. You can see the ruler was across the diameter. And here's, this was a simple bearing. I just want to show you how it's made. And I'm going to want you to describe why that might be a reasonable design. It's very, very simple design. It doesn't have any of the ball bearings or anything in a more sophisticated one. It's an inexpensive design, but it's actually pretty effective. And using physics, I want you to explain why a simple design like that would be so effective. It's basically just metal rubbing directly onto plastic. Why is that an effective bearing for a pulley? And here there was some concern that the ruler was leaning, and here's the front view, and I got a protractor, and it was also leaning backwards a little bit, and here's the side view. I hung a plumb bob, and there you can get the angle, and from the angle you should be able to figure out the difference between the measured drop versus the actual drop, because the ruler wasn't quite straight. Is that significant is the question. And here, what I want you to do is I want to know the mass of these paper clips, or not paper clips, they're clothespins. I got a couple clothespins, and I replaced my head with the clothespins, and I want you to figure that out. I'm going to go back. I'm going to go slower so we can get our frames. Again, this was all shot on the same day. So let's see. Frame at a time. All right, and that's it. Why don't you work on those sources of error, quantify them, and also, now that you have a better idea of how accurate you are because of the, I gave you the mass, the hanging mass, the extra mass, figure out what is the mass of the clothespins. I'm curious, you think this is a more difficult test or an easier test using clothespins versus the 20-gram mass? All right, good luck.
Extreme Physics Deep Dive.